Hello everyone. Today I am presenting my final programming project on solving the closed pair of points problem, a classic in computational geometry. The problem is to find the 2 points that are closed together in a 2D plane. This type of problem is very useful in real world fields like computer graphics for collision detection and rendering, machine learning for clustering and nearest neighbor algorithms, and pattern recognition, where identifying similar features matters. The approach to solve this, I implemented two algorithms in Java. The brute force method, it's the most direct approach. It simply checks every possible pair of points. This works fine when the data set is small, but its time complexity is 0 n squared, so it's quickly becoming slow and insufficient as the number of points increases. Divide and conquer method. This is a much more efficient and smarter strategy. It starts the points first, then recursively divides the dataset in half. Once the dataset is small enough, it falls back on brute force. The key feature is the strip-based comparison, which dramatically reduces the number of point pairs it needs to check. Its complexity is 0 n log n, so it scales much better. Code highlights. Instead of walking through each line, let me give you an overview of how Java program works. I created a point class to represent each point with x and y values. A pair class stores 2 points and the distance between them. The code includes a brute force method to check all pairs and a closed pair divide method that uses sorting, recursion and efficient comparison logic. I also wrote a function to generate random points so I could test the algorithms with large dataset ranging from 10,000 to 20,000 points. Everything was wrapped inside a clean and modular Java class using object-oriented principle for clarity and reusability. Performance and results here where things got really interesting. On smaller datasets, both algorithms performed reasonably well, but as the number of points increased, brute force slowed down drastically. At 20 lakhs points, brute force took over 3 minutes. Meanwhile, the divide and conquer approach handled the same point in under 300 milliseconds. These results clearly confirm the theoretical time complexities. Conclusion: what I learned from this project is that the right algorithm makes all the differences. Even though brute force is easy to write and understand, it just doesn't scale divide and conquer, while slightly more complex is vastly more efficient. And then efficiency really matters when working with large data sets. These projects improved my skills, algorithm designs, performance testing, and writing clean Java code that's structured and reusable. This is the graph and the code in this program project, what I got. Thank you so much.